if I consider this is be a one-dimensional rod, okay, and this is be the axis. Let the end A, this is end B, axis is passing through the end A. If the axis is said to be passing through the end A, then what will be mi of this rod? Who can tell me? Anybody, if you know about it, tell me. What happened? No one knows this? Yes, answer will be ml square by 3. How can you get that? Right, lambda into the element length that we can integrate, and the limit. See, I said that in the last class also. I said that whenever we are supposed to calculate the moment of inertia, okay, whenever we are supposed to calculate the moment of inertia of continuous mass distribution, then the idea of getting mi means you have to consider one element part of that dimensional body. Is as because the dimensional body is a rod of mass m length l, rod of mass m and length l, right? So therefore mass per unit length, that is the lambda, right, which is, in other words, it can also be named to be linear mass density. It is what? It is linear mass density. So being it is linear mass density, so this implies that lambda is basically m by L. So when the mass distribution is done uniformly, okay, then lambda value is taken to be constant. So here lambda will be constant, and on every unit length, the value of lambda, that is m by L. So if we take an element part of the on the rod, that is, let it be of length dx, right? And position of this element is at a distance x from the axis position, that is at A, right? So when the entire rod will be rotated, when the entire rod will be made to rotate about this particular axis, when this will rotate about this axis, so all the element object will rotate about the axis. So mi of the rod will be sum of mi of all elements. So that means we can write down mi of the rod about given axis, right? Mi of the rod about given axis is equal to sum of mi of all element bodies available in the given dimensional rod. So this summation will be done by using the method called integration. So total mi will be I, that will be integration of the value of mi of one such element. So this element may be having the mass dm, and being the element will be treated to be as good as a point object. The element will be treated to be as good as a point object, and we know that for a point object mi expression is given by mass into square of radius, isn't it or not? It will be dm into x square. So the value of dm we can write down using the unitary method. It is lambda into dx. Lambda is the mass on unit length, that into length of the element. So this element's mass we will consider dm, right? So dm can be written lambda dx, that into x square. And for all such elements appearing all along the rod from the end A to the end B, the value of x will keep changing from 0 to the maximum distance, that is L. So that's why limit will be 0 to L. Is that clear? So constant part of this integration term lambda, that can be taken out, and it can be integration of x square dx for limit 0 to L. Are you getting it or not? It will be integration for limit 0 to L. So taking lambda and integration of x square will be x cube by 3 according to the formula. The basic integration formula for algebraic function is x to the power n dx, that we can write down x to the power n plus 1 divided by n plus 1. Okay? Are you getting it? So it is x to the power n dx. So that means this time we can write down it is lambda by 3. If we being 3 being the constant term, we can take it out, right? So then it is lambda cube minus 0, right? And that means this is finally lambda into L cube by 3, and instead of lambda, if you substitute m by L, so it will be m by 3L, that into L cube. So finally it is ml square by 3. So this is the way you can find out the mi of the rod about an axis passing through the end position of the rod and being perpendicular to its length. This is the one idea of getting mi by using integration.